Imagine staring into the night sky, not just seeing stars, but glimpsing at secrets the universe desperately wants to keep hidden. What if those flickering lights and distant whispers aren't just cosmic coincidences, but breadcrumbs left by something else? We're talking about space anomalies, those unexplained phenomena that defy our current understanding of the cosmos and ignite the age-old question, are we truly alone? In this video, we're diving headfirst into 25 of the most baffling space anomalies that have scientists scratching their heads and alien enthusiasts cheering. Prepare to have your perception of reality challenged as we explore compelling evidence that might just change your mind about what's lurking in the shadows of the universe. Get ready to question everything because the truth may be far stranger than fiction. Let's turn our gaze towards one of the most tantalizing whispers from the cosmos, the WOW signal. Back in 1977, the Big Ear radio telescope in Ohio, a sentinel scanning the depths of space, picked up something extraordinary. It was a strong, narrowband radio signal that blazed for 72 seconds, an eternity in cosmic terms. What made it so special? Its intensity was off the charts, far exceeding any background noise, and its frequency, 1,420 MHz, falls within a protected band, a range where radio transmissions from Earth are forbidden, precisely to listen for potential alien chatter. The signal's characteristics screamed artificial, a potential call across the stars. Its very strength and focused nature suggested it wasn't some random cosmic hiccup. Think of it as trying to find a specific note played on a piano in a stadium filled with noise, but this note was crystal clear and impossibly loud. That's the WOW signal. So, why hasn't it been declared definitive proof of extraterrestrial intelligence? The problem is, it's only been detected once. Despite repeated efforts to pinpoint its origin, the signal has never reappeared. This lack of repetition casts a long shadow of doubt. Scientists have proposed numerous natural explanations, from cometary activity to terrestrial interference, but none have fully accounted for the signal's unique properties. One compelling theory suggested a comet releasing hydrogen near the telescope's field of view could mimic the signal, but further analysis debunked this idea. Other suggestions, such as reflections from space debris or unusual atmospheric phenomena, have also fallen short. The fact that so many natural explanations have been examined and dismissed only deepens the mystery. The WOW signal remains an enigma, a tantalizing reminder that we might not yet understand all the ways the universe can speak to us, or perhaps a hint that someone out there is trying to say hello, leaving us to turn our attention to another cosmic puzzle, the strange case of Tabby's star. Now prepare to journey from fleeting signals to a star that's acting rather strangely. We're talking about Tabby's star, also known as KIC 8,462,852, a celestial body that has astronomers scratching their heads. This F-type star, a bit hotter and more massive than our Sun, resides over 1,470 light-years away. What makes Tabby's star so unusual are its light patterns, erratic, deep, and seemingly random dimming events. Unlike the predictable dips in brightness caused by planets orbiting in front of their stars, which we use to find exoplanets, Tabby's star exhibits drops of up to 22%. Imagine a star suddenly losing almost a quarter of its light output, not gradually but abruptly and for varying durations. This is not normal stellar behavior. These strange dimming events have fueled intense speculation, most notably the alien megastructure theory. This hypothesis suggests that an advanced extraterrestrial civilization might have constructed a massive structure, like a Dyson swarm, around the star to harvest its energy. As these structures pass between us and the star, they would cause the observed dimming. It's a captivating idea straight out of science fiction, but one that scientists had to consider. However, there are other, more natural explanations. One leading theory proposes that a large cloud of fragmented comets or dust is orbiting Tabby's star, occasionally passing in front of it and blocking its light. The problem is, for this to cause such significant dimming, the cloud would have to be incredibly massive and dense, something we haven't observed around other stars. Scientists have been diligently observing Tabby's star using telescopes like the Kepler Space Telescope and the Los Cumbres Observatory to gather more data. They've analyzed the star's light at different wavelengths, searching for clues about the composition of the material causing the dimming. Some studies have suggested that the dimming is more pronounced at ultraviolet wavelengths, which could indicate the presence of small dust particles. Despite these efforts, the mystery of Tabby's star persists. While the alien megastructure hypothesis remains a long shot, the natural explanations haven't fully satisfied all the observations. The star continues to surprise us with its unpredictable behavior, reminding us that there's still much we don't understand about the universe and compelling us to look at the origins of fast radio bursts. Diving deeper into the cosmic mystery, we encounter fast radio bursts. Fast radio bursts, or FRB, are intense, millisecond-long bursts of radio waves that originate from distant galaxies. These enigmatic signals possess characteristics that continue to baffle scientists. The energy released during one of these bursts is staggering, comparable to the amount of energy the Sun emits in several days, all compressed into a fleeting millisecond. What makes fast radio bursts particularly intriguing is their unknown origin. Since their discovery in 2007, researchers have been working tirelessly to pinpoint the sources of these bursts. The challenge lies in their transient nature. They appear briefly and then vanish, making them incredibly difficult to trace. However, recent advancements in radio astronomy have allowed for some progress. Various theories attempt to explain the origins of fast radio bursts. Some suggest they are the result of extreme astrophysical events, such as the collision of neutron stars or the eruption of magnetars, which are neutron stars with extremely powerful magnetic fields. These events would release immense amounts of energy in a short period, potentially explaining the bursts. Speculative ideas also include advanced alien technology. The notion that some fast radio bursts could be artificial signals transmitted by extraterrestrial civilizations is a tantalizing, though highly debated, possibility. Proponents of this idea suggest that these bursts could be a form of interstellar communication or the byproduct of advanced propulsion systems. Efforts to trace fast radio bursts back to their sources involve using sophisticated radio telescopes and advanced data analysis techniques. Telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, have been instrumental in detecting and studying FRBs. By analyzing the characteristics of the radio waves, scientists hope to understand the mechanisms that produce them and identify their precise locations. Despite these efforts, identifying where fast radio bursts come from remains a significant challenge. The vast distances they travel and the interference from other cosmic sources complicate the task. Nevertheless, each new fast radio burst discovery brings us closer to unraveling their mystery, pushing the boundaries of our knowledge of the universe. As we continue to explore the cosmos, these signals challenge our current understanding, beckoning us towards the puzzle of the cosmic microwave background cold spot. Transitioning from radio waves to a different kind of cosmic puzzle, we now turn our attention to the cosmic microwave background cold spot. The CMB cold spot is a large region in the cosmic microwave background, or CMB, that stands out due to its significantly lower temperature compared to its surroundings. The cosmic microwave background itself is the afterglow of the Big Bang, the residual radiation that permeates the universe, offering a snapshot of the cosmos in its infancy, approximately 380,000 years after its birth. The temperature of the cosmic microwave background is remarkably uniform across the sky, averaging around 2.725 Kelvin, which is about -457.9 degrees Fahrenheit. However, the CMB cold spot deviates from this average, exhibiting a temperature that is about 70 microkelvins colder. While this might seem like a minuscule difference, its size and distinct temperature variation make it a notable anomaly in the otherwise uniform cosmic microwave background. Several explanations have been proposed to account for the CMB cold spot. One intriguing hypothesis suggests it could be a sign of a parallel universe. According to this theory, the cold spot might be the result of a collision between our universe and another, leaving a mark on the cosmic microwave background. This idea stems from the concept of the multiverse, where numerous universes exist alongside our own, each with potentially different physical laws and constants. Another possible explanation involves what is known as a cosmic texture. Cosmic textures are hypothetical topological defects in the fabric of spacetime formed during the early universe. If a cosmic texture intersected with our observable universe, it could create a temperature variation in the cosmic microwave background, potentially explaining the cold spot. The CMB cold spot is considered an anomaly because it challenges our standard cosmological models. These models predict a certain level of uniformity in the cosmic microwave background, with only slight temperature fluctuations due to the density variations that eventually led to the formation of galaxies and other cosmic structures. The cold spot size and temperature deviation are larger than what these models typically allow, making it a subject of intense scientific scrutiny. Scientists are studying the CMB cold spot through various means to understand its implications for cosmology. High-resolution observations from space-based telescopes, such as the Planck satellite, provide detailed maps of the cosmic microwave background, allowing researchers to analyze the cold spot's characteristics with unprecedented precision. By comparing these observations with theoretical predictions, scientists hope to distinguish between the different hypotheses and gain insights into the nature of the early universe. The study of the CMB cold spot could revolutionize our understanding of the universe, potentially confirming the existence of parallel universes or revealing new physics beyond our current knowledge. As we continue our exploration of space anomalies, we shift our focus to Oumuamua, the first interstellar object detected passing through our solar system, which presents its own set of mysteries. Shifting our perspective from the vastness of the cosmic microwave background to a visitor much closer to home, we now examine Oumuamua. The story of Oumuamua begins in October of 2017, when it was first spotted by the Pan-STARRS telescope in Hawaii. What immediately set Oumuamua apart was its trajectory. Unlike asteroids or comets originating from within our solar system, Oumuamua was traveling at such a high speed that scientists quickly realized it came from interstellar space, making it the first confirmed object of its kind to be observed passing through our neighborhood. Adding to its intrigue was Oumuamua's unusual shape. Estimates suggest it was highly elongated, perhaps resembling a cigar or a pancake, with its length significantly greater than its width. This peculiar shape defied the typical dimensions of asteroids and comets, sparking numerous theories about its origin and composition. Furthermore, Oumuamua exhibited behavior that puzzled astronomers. While it didn't display a visible coma, the cloud of gas and dust typically seen around comets as they approach the Sun, it did show a slight acceleration as it moved away from our star. This non-gravitational acceleration couldn't be fully explained by conventional processes like outgassing, leading to the proposition of more exotic explanations, including the alien probe hypothesis. The debate over Oumuamua's classification as either a comet or an asteroid further complicated its story. Typically, comets release gases as they warm up near the Sun, creating a visible tail. The absence of a clear cometary tail in Oumuamua's case led some to classify it as an asteroid. However, the observed acceleration suggested that some form of volatile expulsion was occurring, albeit invisibly, blurring the lines between the two classifications. Speculation reached new heights when some scientists suggested that Oumuamua might be an alien probe or some form of extraterrestrial technology. This hypothesis, while captivating, faced significant scientific skepticism. The primary argument against it is the lack of any direct evidence supporting artificial construction or propulsion. The alien probe idea hinges on the unexplained acceleration and unusual shape, but natural processes could potentially account for these characteristics. Despite the allure of extraterrestrial explanations, the scientific community largely leans towards natural origins for Oumuamua. Some researchers propose that it could be a fragment of a planet disrupted by its host star or a piece of debris ejected from a binary star system. These scenarios align with known astrophysical processes and don't require invoking alien technology. The mystery of Oumuamua persists because there is no any definitive proof to confirm either its natural or artificial origin. Its brief visit to our solar system allowed for limited observations, leaving many questions unanswered. As it continues its journey into interstellar space, Oumuamua remains an enigma, a cosmic puzzle that challenges our understanding of the universe and the objects that traverse it. As we ponder the mysteries of interstellar visitors, we now turn our attention to an underwater anomaly in the Baltic Sea, a location that offers a different kind of enigma. Transitioning from interstellar mysteries to underwater enigmas, let's navigate to the depths of the Baltic Sea, where we encounter the Baltic Sea Anomaly. This unusual object was discovered in 2011 by a Swedish ocean exploration team named Ocean X while they were searching for a sunken treasure. What they found instead was something far more perplexing, a large circular object resting on the seabed. The Baltic Sea Anomaly is approximately 60 meters in diameter and has a shape that resembles a mushroom or a disc. It features strange patterns and formations on its surface, which some have interpreted as evidence of artificial construction. The object's unusual appearance quickly captured public imagination, leading to speculation that it could be a sunken alien artifact, a remnant of ancient technology, or even a top-secret military device. The speculation that surrounds the Baltic Sea Anomaly often leans towards extraterrestrial origins. Proponents of this idea point to the object's symmetrical shape, the presence of what appear to be constructed features, and the alleged disruption of electronic equipment in its vicinity. Some even suggest that it could be part of a larger structure hidden beneath the seabed, possibly an alien base or a crashed spacecraft. On the other hand, the scientific community largely attributes the Baltic Sea Anomaly to natural geological processes. Geologists suggest that the object could be a glacial deposit, a rock formation shaped by ice age activity, or a volcanic vent. These natural explanations account for the object's shape and surface features without invoking any extraordinary claims. The lack of definitive evidence makes it challenging to determine the true nature of the Baltic Sea Anomaly. The initial images taken by the Ocean X team were of low resolution, making it difficult to discern the object's details. Furthermore, the depth of the Baltic Sea, around 85 meters, and the murky conditions pose significant challenges for investigation. One of the main arguments against the alien artifact theory is the absence of any concrete proof. No samples have been recovered that indicate artificial materials or advanced technology. The features that some interpret as constructed elements could simply be the result of natural erosion and geological processes acting over thousands of years. In summary, the Baltic Sea Anomaly remains an unsolved mystery. While the idea of a sunken alien artifact is tantalizing, the scientific evidence currently available points towards a natural origin. The challenges of investigating the object in its underwater environment mean that we may never know its true nature with complete certainty. As we leave behind the depths of the Baltic Sea and its mysterious anomaly, our journey takes us next to Norway, to a valley known for its unexplained lights. Transitioning from underwater mysteries to atmospheric phenomena, We now turn our attention to the skies above Norway, where the enigmatic Hessdalen lights dance in the night. The Hessdalen Valley, a remote area in central Norway, is renowned for an unusual phenomenon, unexplained lights that appear with regularity. These lights, known as the Hessdalen lights, have been observed since the early 1900s and have attracted both curiosity and scientific inquiry. The Hessdalen lights exhibit a range of characteristics that make them particularly intriguing. They vary in color, often appearing as white, yellow, or orange orbs, though other colors have been reported as well. Their shapes can range from small, fleeting flashes to large, sustained glows that hover in the sky for extended periods. Perhaps most strikingly, their movements are erratic and unpredictable. They can dart across the sky at high speeds, hover motionless, or even pulsate with varying intensity. Numerous scientific investigations have sought to demystify the Hessdalen lights. One prominent theory suggests that the lights are caused by plasma formations. According to this hypothesis, the valley's unique geological composition, rich in metals, could create a natural battery effect. This effect could ionize the air, leading to the formation of plasma balls that manifest as luminous orbs. Geological activity has also been considered as a potential explanation. The Hessdalen Valley sits on a region with known seismic activity, and some scientists propose that the movement of tectonic plates could generate electromagnetic fields. These fields could then interact with atmospheric gases, producing the observed lights. Despite these investigations, a conclusive explanation for the Hessdalen lights remains elusive. While theories involving plasma formations and geological activity offer plausible mechanisms, none fully account for the light's complex behaviors. The varying colors, shapes, and movements observed over the years present a challenge to any single unifying explanation. So, the Hessdalen lights continue to baffle researchers and capture the imagination of those who seek to understand unexplained phenomena. Their persistent presence in the Norwegian sky serves as a reminder that there are still mysteries in our world that defy conventional explanation. As we leave the mysterious glow of the Hessdalen lights behind, we venture next into interplanetary space, where anomalies have been observed in the paths of our own spacecraft, presenting yet another puzzle to unravel. The Pioneer Anomaly. As our cosmic journey continues, we shift our focus from Earth-bound mysteries to anomalies encountered in the vastness of space. The Pioneer 10 and 11 spacecraft, launched in the early 1970s, were among the first to explore the outer solar system. As they journeyed beyond the planets, an unexpected phenomenon emerged, one that has perplexed scientists for decades: the Pioneer Anomaly. The Pioneer Anomaly refers to the small but persistent deviation observed in the trajectories of the Pioneer 10 and 11 spacecraft. Mission controllers noticed that the spacecraft were slowing down more than predicted, as if experiencing an unexpected force acting against their motion. This deviation was tiny, amounting to only a few nanometers per second squared, but it was consistent and defied conventional explanation. Over the years, numerous explanations have been proposed to account for the Pioneer Anomaly. One of the primary candidates was thermal recoil. The spacecraft generated heat from their onboard instruments and radioisotope thermoelectric generators, or RTG. It was theorized that the anisotropic radiation of this heat could exert a tiny but measurable force on the spacecraft, causing them to slow down. Detailed modeling of the thermal properties of the spacecraft was conducted to assess this possibility. Another potential explanation involved gravitational effects. Our understanding of gravity is based on Einstein's theory of general relativity, but some scientists speculated that there might be subtle deviations from this theory at the outer reaches of the solar system. If gravity behaved differently than expected, it could account for the Pioneer Anomaly. Despite extensive research and analysis, the Pioneer Anomaly remains partially unresolved. While thermal recoil appears to explain a significant portion of the observed deviation, it does not fully account for the anomaly. some analyses suggest that there may still be a small, unexplained residual acceleration affecting the spacecraft, and the possibility of mundane explanations such as gas leaks have also been considered. The Pioneer anomaly serves as a reminder that even well-understood physical laws can have unexpected consequences in the extreme environments of space. Now, leaving behind the puzzling trajectories of the Pioneer spacecraft, we turn our attention to the enigma of dark matter, a mysterious substance that makes up a significant portion of the universe's mass, yet remains invisible to our telescopes. Anomaly 9, Dark Matter. Now, venturing into the unseen realms of the cosmos, our attention is captured by one of the most profound enigmas in modern astrophysics, dark matter. Unlike the familiar stars, planets, and galaxies composed of ordinary matter, dark matter is a mysterious substance that does not interact with light, making it invisible to our telescopes. Its presence is inferred solely through its gravitational effects on the visible universe. The evidence for dark matter's existence is compelling and multifaceted. One of the strongest lines of evidence comes from the observed rotation curves of galaxies. According to the laws of physics, the outer regions of galaxies should rotate slower than the inner regions, as there is less visible matter to exert gravitational pull. However, observations consistently show that the outer regions rotate much faster than expected, indicating the presence of additional unseen mass providing extra gravitational force. This discrepancy suggests that galaxies are embedded in a halo of dark matter, which accounts for the excess rotation speed. Further evidence for dark matter arises from the study of galaxy clusters, which are massive collections of galaxies bound together by gravity. Observations of galaxy clusters reveal that they contain far more mass than can be accounted for by the visible galaxies and hot gas within them. This missing mass is attributed to dark matter, which provides the gravitational scaffolding necessary to hold the clusters together. Additionally, gravitational lensing, the bending of light around massive objects, provides another independent measure of the total mass in galaxy clusters. The amount of lensing observed is often much greater than what can be explained by the visible matter alone, further supporting the existence of dark matter. Dark matter is considered an anomaly because it challenges our understanding of the fundamental constituents of the universe. Ordinary matter, composed of protons, neutrons, and electrons, only accounts for a small fraction of the total mass-energy content of the cosmos. The nature of dark matter remains a mystery, prompting intense efforts to identify its fundamental properties and composition. Scientists are pursuing various avenues to directly detect dark matter particles. One approach involves building underground detectors shielded from background radiation, in the hope of detecting rare interactions between dark matter particles and ordinary matter. Another approach focuses on creating dark matter particles in high-energy particle colliders, such as the Large Hadron Collider at CERN. If successful, these experiments could provide crucial insights into the nature of dark matter and its role in shaping the universe. As we grapple with the elusiveness of dark matter, nature continues to tease us with more subtle hints. Our next point comes from the question that arises from the high probability of extraterrestrial civilizations existing and lack of their evidences. Anomaly 10, the Fermi Paradox, turning our gaze towards a question that has haunted scientists and thinkers for decades. We confront the Fermi Paradox, a stark contradiction between the high likelihood of extraterrestrial civilizations existing and the glaring absence of any concrete evidence to support their presence. Named after physicist Enrico Fermi, who famously posed the question during a casual conversation in 1950, the paradox encapsulates the puzzle of why, given the vastness of the universe and the age of the cosmos, we have not yet detected any signs of intelligent life beyond Earth. The implications of the Fermi paradox are far-reaching, challenging our assumptions about the prevalence of life in the universe and our place within it. One proposed solution to the paradox is the rare Earth hypothesis, which suggests that the conditions necessary for the emergence and evolution of complex life are exceedingly rare. According to this hypothesis, while simple life may be common throughout the universe, the development of multicellular organisms, intelligent species, and technological civilizations requires a confluence of factors that are unique to Earth, such as its stable climate, plate tectonics, and the presence of a large moon. Another proposed solution is the Great Filter, which posits that there is a barrier or bottleneck that prevents most, if not all, civilizations from reaching a certain level of technological advancement. This filter could lie in the past, representing a hurdle that life on Earth has already overcome, such as the origin of life itself or the development of complex cells. Alternatively, the filter could lie in the future, representing a challenge that awaits us, such as the depletion of resources, catastrophic climate change, or self-destruction through warfare or technological misuse. If the Great Filter lies ahead, it would suggest that our prospects for long-term survival are precarious, and that we must exercise caution and foresight to avoid triggering our own demise. A more speculative solution to the Fermi Paradox is the possibility that advanced civilizations are deliberately avoiding contact with us. This could be due to a variety of reasons, such as a desire to avoid interference with our development, a fear of attracting hostile attention, or a recognition that we are not yet ready for contact. According to this scenario, extraterrestrial civilizations may be observing us from afar, waiting for us to reach a certain level of maturity or enlightenment before revealing themselves. The Fermi Paradox serves as a reminder of the vastness of the unknown and the limits of our current understanding. As we continue to explore the cosmos and search for signs of life beyond Earth, we must remain open to the possibility that the answers we seek may be more complex and profound than we ever imagined. Reflecting its weight on our understanding, we will delve into another unusual object in the next section of this video. What we're going to talk about is out of this world. Switching gears to a celestial curiosity closer to home, we now turn our attention to the monolith on Phobos, a large rock structure situated on one of Mars' 2 moons. This intriguing formation has sparked considerable speculation regarding its origins, particularly the possibility of it being an artificially constructed object of extraterrestrial design. The monolith, a seemingly rectangular feature, was first identified in 1988 through imagery captured by the Soviet Union's Phobos 2 mission. Its relatively large size compared to Phobos itself, combined with its somewhat geometric shape, led some to suggest that it could not be a naturally occurring phenomenon. Proponents of the alien artifact hypothesis argue that the structure's unusual appearance and prominent placement on the Martian moon implied deliberate construction by an intelligent civilization. They suggest that the monolith could serve as a marker, a monument, or even a piece of advanced technology left behind by extraterrestrial visitors long ago. Conversely, the prevailing scientific view attributes the monolith's formation to natural geological processes. Scientists propose that the structure is likely a large boulder or exposed bedrock feature that has been shaped by impacts, gravitational forces, and other natural phenomena over millions of years. They argue that the monolith's rectangular appearance might be an illusion caused by lighting and viewing angles, or that it could be the result of erosion patterns that have created a somewhat regular shape. The lack of definitive evidence supporting artificial construction is a key point in this argument. Despite the initial excitement and speculation, no subsequent missions to Phobos have provided additional data or imagery that conclusively proves the monolith is anything other than a natural geological formation. While the possibility of an alien origin continues to capture the imagination of some, the scientific consensus remains firmly grounded in natural explanations. The monolith on Phobos serves as a reminder of how our minds can sometimes perceive patterns and meanings where none exist, and how important it is to approach extraordinary claims with a healthy dose of skepticism and a rigorous application of the scientific method. Now, let's adjust our focus from Martian moons to the actual surface of the red planet, where another intriguing discovery awaited. The 12th anomaly focuses on the face on Mars, a rock formation in the Cydonia region of Mars that, from certain angles, appears strikingly like a human face. The story began in 1976, when the Viking 1 orbiter captured images of the Martian surface. Among these images was a peculiar formation that immediately captured the public's imagination. This feature, dubbed the face on Mars, seemed to possess distinct facial features, including what looked like eyes, a nose, and a mouth. The initial excitement stemmed from the tantalizing possibility that this was not a natural formation, but rather an artificial structure, perhaps built by an ancient Martian civilization. Speculation ran wild, with theories suggesting that the face could be a monument, a marker, or even a deliberately crafted signal meant for extraterrestrial observers. The image became a sensation, fueling intense debate and capturing the attention of both scientists and the general public. It seemed to offer tangible evidence that Mars may have once harbored intelligent life. However, as technology advanced and higher-resolution images of the Cydonia region became available, the mystery surrounding the face on Mars began to unravel. Subsequent missions, including the Mars Global Surveyor and Mars Reconnaissance Orbiter, provided much clearer images of the formation. These higher-resolution images revealed that the face was in fact a natural geological feature. What appeared to be facial features in the original, lower-resolution images were simply the result of shadows and the limited detail captured by the Viking 1 orbiter. The improved imagery showed a rugged, eroded mesa-like structure with no clear evidence of artificial construction. While the initial mystery fueled interest in the possibility of extraterrestrial life and spurred further exploration of Mars, the face on Mars ultimately proved to be a product of natural processes and pareidolia, the human tendency to see familiar patterns in random stimuli. Even though it was debunked as an alien construct, it remains as one of the most fascinating and widely recognized stories blurring the lines between science, speculation, and the enduring question, are we alone? From faces on Mars to something even stranger in Earth's orbit, let's turn our attention to the legend of the Black Knight satellite. The 13th anomaly turns our gaze towards Earth's orbit again, focusing on the legend of the Black Knight satellite, a purported artificial satellite orbiting Earth that has been the subject of conspiracy theories for decades. The Black Knight is not a physical object confirmed by any space agency, but rather an idea that has evolved through various misinterpreted events and speculations, becoming a staple of UFO lore. The story of the Black Knight can be traced back to 1954, when newspapers reported that the United States Air Force had detected 2 satellites orbiting Earth, a time when neither the U.S. nor the Soviet Union had the capability to launch such objects. These reports were later clarified as misinterpretations of radar blips tracking something else entirely, but the seed of an orbiting mystery had been planted. Over the years, various images and stories have been associated with the Black Knight. One popular claim involves a series of images taken during a 1998 Space Shuttle mission, STS-88, which some UFO enthusiasts claim depict the Black Knight. However, these images actually show a thermal blanket that was lost during an extravehicular activity. The blanket, part of the equipment used to insulate the International Space Station, simply floated away and was photographed as it drifted in orbit. Another aspect of the Black Knight myth involves purported radio transmissions received from the satellite. These transmissions are often linked to a map said to originate from the Epsilon Boötis star system, interpreted as an invitation to visit Earth. However, these claims are largely based on misinterpreted signals and lack any verifiable evidence. Despite the debunking of its various supposed sightings and signals, the myth of the Black Knight satellite persists in popular culture, fueled by a combination of genuine mysteries, misinterpreted data, and the human desire to believe in something extraordinary. The legend illustrates how speculation and misinformation can combine to create enduring myths, particularly when they tap into our fascination with space and the unknown. From a supposed alien satellite, we move to the depths of the solar system, to the edge of our planetary system. Stepping away from Earth-bound mysteries, we venture to the icy edges of our solar system to explore the Kuiper Cliff, a peculiar feature located within the Kuiper Belt. The Kuiper Belt is a circumstellar disk in the outer solar system, extending from the orbit of Neptune at 30 astronomical units to approximately 50 astronomical units from the Sun. It is similar to the asteroid belt but is far larger and more massive. It is populated with many icy bodies, including dwarf planets such as Pluto and Haumea, and countless smaller objects. However, beyond about 48 astronomical units, the density of Kuiper Belt objects drops off dramatically, creating what is known as the Kuiper Cliff. This sharp decline in the number of objects is not what scientists initially expected, and several theories have been proposed to explain this anomaly. One intriguing explanation involves the gravitational influence of a hypothetical planet 9, also known as Planet X. This theoretical planet, much larger than Earth, is proposed to orbit the Sun at a great distance far beyond the known planets. Its gravity could be responsible for clearing out or scattering objects in the outer Kuiper Belt, leading to the observed cliff. Another possible explanation relates to the effects of primordial planetesimals. These are small bodies that existed in the early solar system and played a role in the formation of planets. It has been suggested that collisions and gravitational interactions among these planetesimals could have gradually eroded the outer edge of the Kuiper Belt over billions of years. The Kuiper Cliff is considered an anomaly because it challenges our understanding of how planetary systems form and evolve. The standard models of solar system formation predict a gradual decline in the density of objects with increasing distance from the Sun, not a sudden drop-off. Scientists are actively studying the Kuiper Cliff using telescopes and computer simulations to gather more data and test different hypotheses. These studies aim to understand the distribution of objects in the Kuiper Belt, identify any patterns or groupings, and model the gravitational forces that may be at play. The discovery of new Kuiper Belt objects and the refinement of our understanding of the dynamics of the outer solar system could eventually solve the mystery of the Kuiper Cliff. As we continue to probe the edges of our solar system, our curiosity turns to planets that defy our conventional wisdom. Transitioning from the icy realms of our solar system, our attention now shifts to distant stars and the exotic planets that orbit them. The study of exoplanets, planets orbiting stars other than our Sun, has revealed a zoo of worlds that challenge our conventional understanding of planetary formation. These unusual extrasolar planets are considered anomalies because their existence defies the predictions of standard planetary formation theories, which were primarily developed based on observations within our own solar system. Among the most perplexing of these alien worlds are the hot Jupiters. These are gas giant planets similar in size and composition to Jupiter, but orbiting incredibly close to their host stars, often much closer than Mercury orbits our Sun. Their proximity results in scorching temperatures, hence the name hot Jupiters. The conventional theory of planetary formation suggests that gas giants should form far from their stars, in the colder outer regions of a protoplanetary disk, where icy materials can accumulate to form a massive core. This core then attracts gas from the surrounding disk, eventually growing into a gas giant. However, the existence of hot Jupiters suggests that these planets formed further out and then migrated inward, a process known as planetary migration. Several mechanisms have been proposed to explain this migration, including gravitational interactions with the protoplanetary disk or with other planets in the system. Another class of unusual exoplanets is rogue planets, also known as free-floating planets. These are planets that do not orbit a star but instead wander through interstellar space. Rogue planets can form in several ways. They may be ejected from a planetary system due to gravitational interactions with other planets or stars, or they may form independently from collapsing clouds of gas and dust, similar to how stars form. The discovery of rogue planets raises questions about the prevalence of planets in the galaxy and the processes that can lead to their ejection from planetary systems. Planets with highly eccentric orbits also present a puzzle for planetary scientists. In our solar system, most planets have nearly circular orbits. However, many exoplanets have highly elongated or eccentric orbits, meaning their distance from their star varies greatly over the course of their orbit. These eccentric orbits can be caused by gravitational interactions with other planets in the system or with a passing star. Planets with highly eccentric orbits experience extreme seasonal variations, with dramatic changes in temperature as they move closer to and further from their star. These unusual extrasolar planets challenge our understanding of planetary systems because they demonstrate that planetary formation and evolution can be much more complex and diverse than we initially thought. The discovery of these anomalies has spurred the development of new theories and models to explain the wide range of planetary systems that exist in our galaxy. As we continue to explore the cosmos, we will keep discovering planets that challenge our current theories. Next up, we'll explore a region of seemingly empty space. Now, venturing into the expansive emptiness of space, we encounter the Boötes Void, an extraordinarily large region of space that contains very few galaxies. Sometimes called the Great Void, it's one of the largest known voids in the universe, spanning nearly 330 million light-years in diameter. For perspective, if our Milky Way galaxy were placed at the center of the Boötes Void, we wouldn't discover another galaxy until we traveled over 165 million light-years in any direction. The emptiness of the Boötes Void is quite striking because, statistically, a region of this size should contain thousands of galaxies based on the average distribution of matter in the cosmos. Instead, scientists have found only about 60 galaxies within the void. This stark contrast between expectation and observation is what makes the Boötes Void a significant anomaly. Several explanations have been proposed to account for the void's unusual emptiness. One leading hypothesis suggests that the Boötes Void formed through the merger of smaller voids over billions of years. In the early universe, numerous smaller voids existed, and as the universe expanded, these voids gradually coalesced into larger ones. According to this theory, the galaxies that were originally located in these smaller voids were pulled toward the edges of the newly formed, larger void, resulting in the vast, empty space we observe today. Another possible explanation involves the gravitational influence of dark matter, the mysterious substance that makes up a significant portion of the universe's mass but does not interact with light. It's hypothesized that concentrations of dark matter around the Boötes Void may have influenced the distribution of galaxies, preventing them from entering or remaining within the void. While dark matter itself is invisible, its gravitational effects can shape the structure of the cosmos, potentially contributing to the formation and maintenance of large voids like the Boötes Void. The Boötes Void is considered an anomaly because it challenges our understanding of the large-scale structure of the universe. Cosmological models predict a certain distribution of galaxies and voids, but the extreme emptiness of the Boötes Void deviates significantly from these predictions. By studying this void, scientists hope to gain insights into the processes that govern the formation and evolution of cosmic structures, including the roles of gravity, dark matter, and the expansion of the universe. Scientists are studying the Boötes Void using various observational techniques. They are mapping the locations of the galaxies within and around the void to understand their distribution and movements. They're also studying the properties of the void itself, such as its shape, size, and density, to compare it with theoretical models. Additionally, scientists are using computer simulations to model the formation of voids and to test different scenarios for how the Boötes void might have evolved over time. These studies contribute to our broader understanding of the cosmic web, the network of galaxies, filaments, and voids that make up the large-scale structure of the universe. These simulations help refine our understanding of how galaxies cluster together and how voids like Boötes can arise and persist. From an emptiness that defies our very understanding of space, we now move on to something even more dense and puzzling. Now shifting our focus from cosmic voids to celestial bodies, let's explore the intriguing world of metallic asteroids, specifically asteroids like 16 Psyche. These asteroids stand out because, unlike most asteroids that are rocky or icy, they are primarily composed of iron and nickel. The discovery of these metallic asteroids has presented a fascinating puzzle to astronomers, challenging our understanding of asteroid composition and planetary formation. 16 Psyche, one of the most well-known metallic asteroids, orbits the Sun in the asteroid belt between Mars and Jupiter. Its estimated diameter is about 140 miles, making it one of the largest asteroids in the asteroid belt. What sets 16 Psyche apart is its composition, which is thought to be almost entirely iron and nickel, similar to the Earth's core. This composition has led scientists to believe that it may be the exposed core of an early planetesimal, a building block of a planet that was stripped of its outer layers during the early solar system's chaotic period. The possible origins of metallic asteroids like 16 Psyche are linked to the violent processes that occurred during the solar system's formative years. One prevailing theory suggests that these asteroids are the remnants of shattered planetary cores. In the early solar system, numerous protoplanets or embryonic planets formed and collided with each other. During these collisions, the outer layers of these protoplanets could have been stripped away, leaving behind the dense metallic cores. These cores then cooled and solidified into the metallic asteroids we observe today. Another possibility is that metallic asteroids formed through a process called differentiation within early planetesimals. In this scenario, as the planetesimal melted due to radioactive decay and collisions, heavier elements like iron and nickel sank to the center, forming a metallic core. If the planetesimal was subsequently disrupted by a collision, the core could have been exposed and become a metallic asteroid. Metallic asteroids are considered anomalies because their composition is quite different from the majority of asteroids, which are primarily rocky or icy. Their existence raises questions about the processes that led to their formation and the conditions in the early solar system. Studying metallic asteroids can provide valuable insights into the formation of planets. Because they may represent the exposed cores of early planetesimals, they offer a unique opportunity to study the composition and structure of planetary interiors without having to send probes to the cores of actual planets. Furthermore, metallic asteroids could potentially be valuable resources for future space exploration. The iron and nickel they contain could be mined and used to construct structures in space or to produce fuel and other resources. This has led to discussions about the possibility of asteroid mining and the economic potential of these metallic bodies. As we continue to probe the asteroid belt, our focus shifts to a more peculiar cosmic puzzle that confounds astronomers to this day. Transitioning our attention to another star system, let's explore the debris disk around Epsilon Eridani, a younger, Sun-like star located about 10.5 light-years away. This star is surrounded by a circumstellar disk of dust and gas, similar to our own solar system's Kuiper belt, but far more active and complex. The debris disk around Epsilon Eridani exhibits unusual structures and gaps that have intrigued astronomers for years. These features suggest that the disk is not a uniform, featureless ring, but rather a dynamic environment shaped by various forces and objects. One of the most striking features of the Epsilon Eridani debris disk is its distinct ring-like structure. The disk is not a continuous sheet of dust, but is instead concentrated into several distinct rings at different distances from the star. These rings are thought to be formed by the gravitational influence of unseen planets within the system. Just as Jupiter's gravity sculpts the asteroid belt in our solar system, planets orbiting Epsilon Eridani could be clearing out regions of the disk and trapping dust particles into rings. The gaps within the Epsilon Eridani debris disk are another intriguing feature. These gaps are regions where the density of dust particles is significantly lower than in the surrounding rings. One possible explanation for these gaps is the presence of unseen planets orbiting within the disk. These planets could be sweeping up dust and gas in their orbital paths, creating gaps in the disk. Another possibility is that the gaps are caused by gravitational interactions with other stars in the vicinity. Epsilon Eridani is part of a triple star system, and the gravitational influence of the other two stars could be disrupting the debris disk. The Epsilon Eridani debris disk is considered an anomaly because its structure and composition are quite different from those of other debris disks around similar stars. Its unusual features suggest that the system is undergoing active planet formation or has experienced significant gravitational interactions. Studying the Epsilon Eridani debris disk provides valuable clues about the formation of planetary systems. By observing the disk's structure and composition, astronomers can learn about the processes that shape planetary systems and the conditions that are necessary for planet formation. The gaps and rings in the disk can reveal the presence and orbital characteristics of unseen planets, helping us understand how planets form and evolve in young star systems. Shifting our focus to another source of intrigue, we now turn our attention to repeating radio signals emanating from the depths of space. Embarking on an exploration of the cosmos's enigmatic broadcasts, let's focus on the discovery of repeating radio signals from space. These signals, detected by advanced observatories like the Canadian Hydrogen Intensity Mapping Experiment, known as CHIME telescope, are brief bursts of radio waves that originate from distant galaxies. What sets them apart is their recurring nature, a characteristic that defies easy explanation and has ignited the curiosity of scientists worldwide. The CHIME telescope, located in British Columbia, Canada, is particularly adept at detecting these fast radio bursts because of its wide field of view and high sensitivity. Since it began operating, CHIME has discovered a significant number of repeating fast radio bursts, greatly increasing our understanding of this phenomenon. The possible sources of these repeating radio signals are varied, ranging from natural astrophysical phenomena to more speculative ideas. Pulsars, which are rapidly rotating neutron stars that emit beams of electromagnetic radiation, are one potential source. Magnetars, another type of neutron star with extremely powerful magnetic fields, are also considered possible candidates. These objects are known to produce strong radio emissions, and under certain conditions, their signals could appear to repeat over time. However, the repetitive nature of these signals has also led to more intriguing, albeit speculative, theories. One such idea is that the signals could be artificial in origin, potentially generated by extraterrestrial intelligence. While this remains a long shot, the possibility cannot be ruled out entirely, especially given the challenges in explaining these signals with known astrophysical processes. The repeating nature suggests a level of regularity and control that is not typically associated with natural phenomena, fueling the debate and driving further investigation. These repeating radio signals are considered anomalies because they challenge our current understanding of the universe and the types of objects and events that can produce such signals. Their origin remains largely unknown, and the existing theories struggle to fully account for their observed characteristics. Scientists are working diligently to decode these messages by analyzing their patterns, frequencies, and other properties. The goal is to identify any potential structure or information encoded in the signals that could shed light on their source and nature. Sophisticated algorithms and data analysis techniques are being employed to sift through the vast amounts of data collected by radio telescopes, searching for any clues that could help unravel this cosmic mystery. As we continue to probe the secrets of these repeating radio signals, the possibility of a groundbreaking discovery looms large, potentially reshaping our understanding of the universe and our place within it. Having considered the enigma of these repeating signals, we now turn our attention to a very nearby star and the strange transmissions received in its direction. Transitioning from the search for signals in space to phenomena that affect the very fabric of the cosmos, we now confront the mystery of dark energy, the enigmatic force driving the accelerated expansion of the universe. Dark energy is not something we can directly observe or measure in a lab. Instead, its existence is inferred from its effects on the universe's expansion. The prevailing model of cosmology suggests that the universe is composed of about 68% dark energy, 27% dark matter, and only 5% ordinary matter. Unlike dark matter, which attracts and clumps galaxies together, dark energy acts as a repulsive force, pushing everything apart at an ever-increasing rate. This accelerated expansion was unexpectedly discovered in the late 1990s, shaking the foundations of cosmology and earning the discoverers the Nobel Prize in Physics in 2011. The primary evidence for dark energy comes from observations of distant supernovae, specifically Type 1, a supernova, which serve as standard candles because of their consistent brightness. By measuring the distance to these supernovae and comparing it to their redshift, which indicates how much the light has been stretched due to the expansion of the universe, scientists found that they were farther away than expected. This suggests that the universe's expansion has not been constant but is accelerating, implying the existence of a force counteracting gravity on a cosmic scale. Additional evidence comes from the cosmic microwave background, known as CMB, the afterglow of the Big Bang. The CMB provides a snapshot of the universe in its infancy and contains subtle temperature fluctuations that reveal information about the universe's geometry and composition. Analyses of the CMB have shown that the universe is spatially flat, meaning that its overall density is very close to a critical value. However, the amount of ordinary and dark matter we can detect accounts for only about 30% of this critical density, implying that the remaining 70% must be in the form of dark energy. Dark energy is considered one of the biggest anomalies in modern cosmology because it challenges our understanding of gravity and the fundamental laws of physics. The simplest explanation for dark energy is the cosmological constant, a term introduced by Albert Einstein into his theory of general relativity. The cosmological constant represents a uniform energy density that permeates all of space, exerting a constant negative pressure that drives the expansion of the universe. However, the observed value of the cosmological constant is vastly smaller than what is predicted by quantum field theory, creating a significant discrepancy known as the cosmological constant problem. Scientists are actively trying to understand the nature of dark energy through various observational and theoretical approaches. Large-scale surveys of galaxies are mapping the distribution of matter in the universe, providing further constraints on the properties of dark energy. Theoretical models such as quintessence propose that dark energy is not a constant but a dynamic field that evolves over time. These models attempt to address the cosmological constant problem by introducing new physics beyond the standard model of particle physics. The quest to unravel the mystery of dark energy promises to deepen our understanding of the universe and its ultimate fate, with ongoing research poised to reveal whether dark energy is a constant force or a more complex, evolving phenomenon. Having explored the expansive effects of dark energy, we now redirect our gaze toward a nearby star system and the peculiar signals it emits, a beacon potentially hinting at more than just stellar activity. Turning our attention from the vastness of dark energy to a cosmic next-door neighbor, we now examine the strange signals detected from the direction of Proxima Centauri, the closest star to our Sun, by the Breakthrough Listen project. In 2020, astronomers analyzing data from the Parkes telescope in Australia uncovered a curious radio signal designated BLC-1, short for Breakthrough Listen Candidate 1. This signal piqued their interest not only because it originated from the vicinity of Proxima Centauri, but also due to its unique frequency and behavior. The characteristics of BLC-1 set it apart from typical radio interference. It was a narrow-band signal, meaning its energy was concentrated in a very small range of frequencies. Natural radio emissions from astrophysical sources tend to be much broader, so the narrowness of BLC-1 suggested a possible artificial origin. The signal also exhibited a slight drift in frequency, which could be indicative of a transmitter moving relative to the telescope. This drift is the kind of signal one might expect from a technology orbiting a planet. Even more intriguing, BLC-1 appeared to be present in only one observation session and was not detected again in subsequent observations, adding to the mystery. The possibility that BLC-1 could be artificial immediately sparked intense interest and speculation. Proxima Centauri is a red dwarf star known to host at least 2 planets, one of which, Proxima Centauri b, resides within the star's habitable zone. This means that Proxima Centauri b could potentially have liquid water on its surface, an essential ingredient for life as we know it. While red dwarf stars are known for their intense stellar activity, which could pose challenges for life, the presence of a potentially habitable planet made the Proxima Centauri system an attractive target in the search for extraterrestrial intelligence. In response to the discovery of BLC-1, scientists initiated a series of investigations to determine whether the signal was indeed extraterrestrial in nature or simply a form of terrestrial interference. They analyzed the data in detail, examining the signal's properties and searching for any signs of human-made sources. They also looked for similar signals in other datasets and conducted follow-up observations of Proxima Centauri to see if BLC-1 would reappear. Despite extensive investigation, scientists have not yet been able to definitively identify the source of BLC-1. While the possibility of extraterrestrial technology has not been ruled out, it remains the less likely explanation. Terrestrial interference, such as that from a malfunctioning satellite or a previously unknown source of human-made radio signals, is a more probable explanation. The scientific investigations are ongoing, and future observations and analyses may eventually reveal the true nature of this enigmatic signal. From potential signals from nearby stars, we now move to a hypothetical planet lurking in the outer reaches of our own solar system. Transitioning from the realm of potential radio signals to the possibility of hidden planetary bodies, we will delve into the story of Planet 9. Planet 9 is a hypothetical planet in the outer solar system. It is thought to be responsible for the clustering of trans-Neptunian objects. These are small icy bodies that orbit the Sun beyond Neptune. The story of Planet 9 began in 2014, when astronomers noticed something peculiar about the orbits of several of these distant objects. The evidence for Planet 9's existence lies primarily in the unique orbital alignment of certain trans-Neptunian objects. These objects, which include dwarf planets like Sedna and several others, have orbits that are clustered together in a way that is highly improbable if they were randomly distributed. Specifically, their orbits share similar orientations and tilt angles, a pattern that suggests they are being influenced by a common gravitational force. This clustering effect has led scientists to propose that a large, unseen planet is gravitationally sculpting the orbits of these smaller bodies, pushing them into their observed configurations. The calculations suggest that this hypothetical planet would be several times more massive than Earth, possibly similar in size to Neptune, and would orbit the Sun at a great distance far beyond the orbit of Pluto. Planet 9 is considered an anomaly because its existence challenges our current understanding of how planetary systems form and evolve. According to the standard models of planet formation, planets typically form closer to their star and then migrate outward through interactions with the protoplanetary disk. However, it is difficult to explain how a planet as massive as Planet 9 could have formed in the outer solar system, where the density of matter is very low. One possibility is that Planet 9 formed closer to the Sun and was later ejected into its current distant orbit through gravitational interactions with other giant planets, such as Jupiter and Saturn. Alternatively, it may have been captured from another star system. The search for Planet 9 is ongoing, with astronomers using advanced telescopes to scan the outer solar system for any sign of its presence. These telescopes include the Subaru Telescope, the Very Large Telescope, and the future Vera C. Rubin Observatory, which is expected to revolutionize our understanding of the outer solar system when it comes online. The search is challenging because Planet 9, if it exists, would be very faint and difficult to detect due to its great distance from the Sun. However, astronomers are using sophisticated techniques to analyze the data and identify potential candidates. If Planet 9 is found, it would not only be a major discovery in its own right, but it would also provide valuable insights into the formation and evolution of our solar system and the prevalence of planetary systems around other stars. As we continue to search our outer solar system, a closer look reveals even more mystery. We turn our attention back to Tabby's star with updated information and recent studies to uncover more. The Tabby star redux reveals that the story of KIC 8462852, or Tabby star, is far from resolved and in fact has become even more perplexing with new data and continued observation. Since its initial discovery, the star has continued to exhibit unpredictable dimming events, defying any simple explanation. Recent studies have shown that not only does the star dim erratically in short bursts, but it also displays a long-term dimming trend that spans years. This dual behavior complicates the picture, suggesting that multiple mechanisms may be at play. Updated information includes detailed analysis of the star's light curves from various telescopes, including the Kepler Space Telescope and ground-based observatories. These data sets reveal that the dimming events are not periodic, ruling out simple explanations like a planet transiting the star. One intriguing finding is that the depth and duration of the dips vary significantly, with some events causing the star's brightness to drop by as much as 22%. Moreover, the color of the light from Tabby's star appears to change slightly during these dimming events, indicating that the material blocking the light is not uniform in composition. New theories attempting to explain Tabby's star focus on complex astrophysical phenomena. One such theory suggests that the dimming is caused by a swarm of disintegrating comets orbiting the star. As these comets break apart, they release dust and gas that temporarily block the star's light. However, this theory struggles to explain the long-term dimming trend. Another hypothesis involves circumstellar dust clouds that are irregularly distributed around the star. These clouds could be the result of collisions between asteroids or the tidal disruption of a large object. Recent observations have also explored the possibility of intrinsic variability within the star itself, although this remains a less favored explanation due to the star's otherwise normal spectral characteristics. Additional data and observations that further complicate the mystery include the lack of infrared excess, which would be expected if there were a large amount of dust surrounding the star. This absence challenges the comet and dust cloud theories, as these scenarios would typically produce detectable infrared radiation. Furthermore, high-resolution imaging has failed to reveal any companion stars or massive planets that could be influencing the star's behavior. Despite extensive research and numerous proposed explanations, Tabby's star continues to resist a definitive answer, solidifying its status as one of the most enigmatic objects in our galaxy and fueling speculation about unconventional explanations. As the mystery deepens, we turn our gaze to another radio source, exhibiting strange behavior by appearing and disappearing over time, challenging astrophysical events. The 24th anomaly involves the unidentified radio source GCRTJ 1745-3009, a celestial enigma that has puzzled astronomers since its discovery. This radio source is unique due to its intermittent nature, appearing and disappearing over time in a manner that defies conventional astrophysical explanations. Unlike typical radio sources such as pulsars or quasars, GCRTJ 1745-3009 emits sporadically, with periods of activity followed by prolonged silence, making it difficult to study and categorize. The behavior of GCRTJ 1745-3009 challenges our understanding of typical astrophysical events because its on-again, off-again emissions do not fit neatly into established models. One of the most perplexing aspects of this source is the rapidness with which it can switch on and off. During its active phases, it emits strong bursts of radio waves, but these bursts are fleeting, often lasting only a few minutes to a few hours. Then, just as suddenly, the source goes silent for extended periods. This unpredictable behavior sets it apart from other known radio sources, most of which exhibit more consistent and predictable emission patterns. Various theories have been proposed to explain the unusual behavior of GCRTJ 1745-3009, but none have fully accounted for its peculiar characteristics. One hypothesis suggests that it could be a rotating radio transient, a type of neutron star that emits radio waves only when its magnetic pole aligns with our line of sight. However, the observed emission properties of GCRTJ 1745-3009 do not perfectly match those of known rotating radio transients. Another possibility is that it could be a binary system involving a compact object, such as a black hole or neutron star, interacting with a companion star. In this scenario, the radio emissions could be triggered by accretion events, where material from the companion star falls onto the compact object. Despite these efforts, the true nature of GCRTJ 1745-3009 remains a mystery. Continued observations and analysis are needed to gather more data and potentially uncover new clues about its origin and emission mechanisms. As scientists explore the cosmic puzzle, our journey concludes by continuing efforts to search for extraterrestrial techno-signatures. The 25th anomaly encompasses the ongoing search for extraterrestrial techno-signatures, a pursuit driven by the quest to detect any observable signs of advanced technology beyond Earth. This endeavor involves a diverse array of projects and initiatives, each employing unique methods and technologies to scan the cosmos for telltale indicators of intelligent life. These techno-signatures could manifest in many forms, including radio signals, optical flashes, megastructures, or even atmospheric pollutants, each potentially revealing the presence of a distant civilization. The search for extraterrestrial intelligence, known as SETI, stands at the forefront of this search, primarily focusing on the detection of artificial radio signals. Using large radio telescopes like the Allen Telescope Array and the Green Bank Telescope, SETI projects scan the skies for narrowband radio transmissions that mimic the patterns of human-made signals. These signals are analyzed for non-natural patterns, which would distinguish them from naturally occurring cosmic phenomena. Another approach involves searching for optical signals, such as powerful laser pulses, which could be used for interstellar communication. The challenge lies in distinguishing these potential signals from terrestrial interference and natural astrophysical events, requiring sophisticated signal processing techniques and rigorous verification protocols. Beyond radio and optical searches, there are more speculative but equally intriguing efforts to detect other types of techno-signatures. Some scientists are exploring the possibility of identifying megastructures such as Dyson spheres, hypothetical structures built around stars to capture their energy. These structures could potentially alter the light emitted by a star in detectable ways. Others are investigating the possibility of detecting artificial chemicals in the atmospheres of exoplanets, which could indicate industrial activity. These approaches face immense technical challenges, but the potential payoff finding definitive evidence of extraterrestrial intelligence makes them worthwhile. The implications of discovering extraterrestrial intelligence would be profound, forever altering our understanding of the universe and our place within it. Such a discovery would not only confirm that we are not alone, but also provide insights into the potential capabilities, motivations, and longevity of advanced civilizations. It could revolutionize fields ranging from science and technology to philosophy and religion, prompting us to re-evaluate our assumptions about life, the universe, and everything. From SETI initiatives to the search for unusual signals from Proxima Centauri, the quest to find extraterrestrial life pushes the boundaries of human knowledge and ignites our collective imagination. As we draw to a close on our journey through 25 of the most perplexing space anomalies, it becomes clear that while science has offered explanations for some, many mysteries persist, continuing to ignite our curiosity about the possibility of extraterrestrial life. From the unexpected strength and enigmatic source of the WOW signal to the baffling dimming patterns of Tabby's star, each anomaly serves as a stark reminder of how much we still don't understand about the cosmos. The nature of fast radio bursts, the characteristics of dark matter and dark energy, and the implications of objects like Oumuamua all challenge our current knowledge and force us to consider unconventional explanations. These anomalies are not merely isolated incidents, they represent fundamental gaps in our understanding of physics, astrophysics, and the potential for life beyond Earth. The Fermi Paradox, the Pioneer Anomaly, the CMB cold spot, and even the legends of structures like the face on Mars and the Black Knight satellite, despite being largely debunked, continue to capture our imagination and drive the search for answers. Whether these mysteries ultimately yield evidence of alien civilizations remains to be seen, but the quest to unravel them pushes the boundaries of science and inspires new generations of researchers and enthusiasts. The exploration of space anomalies isn't just about finding aliens, it's about expanding our understanding of the universe, challenging our assumptions, and fostering a sense of wonder and curiosity. We invite you to continue this exploration, to question the unknown, and to share your own theories and insights in the comments below. What do you think about these anomalies? Do they suggest the presence of life beyond Earth? What other mysteries should we be exploring? If you found this journey through space anomalies thought-provoking, please like this video, share it with fellow space enthusiasts, and subscribe to our channel for more deep dives into the mysteries of the universe. Hit the notification bell so you do not miss any future explorations into the unknown, and together we can continue to unravel the secrets of the cosmos.